Hello everyone and welcome on this 2025 edition of the Status of Embedded Linux. Yay. You are in the right room. All right? So what is this talk? We periodically look at things that happened and we present you what we found interesting. So sorry if your preferred events didn't make to the list. The first and the best way to make them on the list is to tell us. And there are two parts, the going fast around many things, and then the teams part, and we have some bonus this year also. So the general outline, we have the Linux kernel, we have technology areas, industry news, community, that is mostly conferences this year, and conclusions with bonus. So let's start with the Linux kernel, mostly based by the coverage from the LWN. So this slide is showing the release cycles of the Linux kernel versions, and the only interesting thing in there is the holiday schedule. So let's go forward to the next one. We start from 6.12 that was released in November last year. So if you still remember that there was a time that there wasn't preempt-MT in the Linux kernel, that's less than a year. So it has been merged. Security modules got use of the static system calls instead of indirect function calls for better performance security, the tracing ring buffer that persists across reboot, and a new security module for fixed functionality devices. Interesting for embedded people. Then, the big feature also of 6.12 was the addition of SCAD-X. So you can now write your own scheduling as a BPF program. That was expected to be merged in 11, but as for any features like that, there were discussions, and finally it landed in 12. And there are a lot of resources that you can use if you want to write your own schedule instead in BPF, instead of hacking the kernel and changing things in there. Then 6.12 has been also selected by the Civil Infrastructure Platform for its next very long time support release for the next 10 years. And yeah, they have an announcement on that. Then 6.13. ARM64 can run Linux in virtual machine under the ARM confidential computing architecture. Shadow stacks also for ARM64. More preemption work, this time lazy preemption, thermal thresholds, and a milestone for the Rust development, enough so that it was possible to implement binder using this infrastructure. What can be interesting for embedded is also we got multi-grain timestamp in the VFS, so low resolution, high resolution, and in such a way so that high res only if needed. You can install guard pages at a specific address range, and some old things have been removed through the RiseFS. Yeah. 14 March. The new XCVE, when I'm reading this one, I'm always thinking about security. But well, naming, as we know, is a complicated problem. So a program can ask the kernel to give information if a file is executable or not. So you can implement a security checks for scripts. You also have a daemon control graph controller that can be used to regulate access to device memory, and I/O ring in Fuse. Of course, as usual, there are resources if you want to read more about those things. 6.15, so we are in May this year. New kernel command line trace off after boot that disables tracing when init process starts. So it could be interesting. And Fuse supports handling timeout. So if a user space hangs for a reason, there's a way to get out of the situation. 16. So latest up to date, lazy preemption on ARM64, core dumps that you can redirect to Unix sockets, and the big improvements in X4 file systems. Other things are also here on the slide for further reference. What has landed in for 6.17 so far? The big change, even single processor configuration will be running SMP kernel by removing, well, a lot. For the real-time initial support for proxy execution, USB audio offload, more speed up on the XT4, BPF becoming more and more like real programs now having std out and error streams, and the monitor for real-time app problems. And yet that's how the LWN the Linux kernel download site looks like. We are probably quite up to date with this one. So everything is related, is released quite frequently, and 5.4 has gone way over the 8-bit mark, if you want to encode the version on 8 bits. The contributions by embedded Linux companies. Some people like this slide with statistics on which company has had how many commits for the last year, and then the top contributor from the company. That doesn't mean that that person did all of that, right? And then what kind of work that person did. We can see that there's a big range of various types of activities, from GPUs to networking and processor support. So we are getting a lot of work from embedded Linux companies.
Yeah, if I can just jump in there. One thing I think is pretty interesting is you'll see that there's a spread of companies working on different SoCs, right? So you got Qualcomm SoCs. I was very excited to see MediaTek being done by Collabora, and so a lot of great work being done in terms of upstreaming by a lot of these independent embedded consultant companies.
Development statistics, they are stable, basically. That's what we can say from those diagrams. 6.16, more than 2,000 developers, nearly 15,000 non-merged commits. So going pretty steady and fast.
So let's talk about an upcoming topic. So this, oh, okay. there was a talk in Denver at Open Source Summit North America that I think surprised a lot of people. So Sasha Levine, who's one of the top maintainers, he primarily focuses on the long-term stable trees and backporting fixes to that, said that he had submitted a patch that he used AI to write. And it was accepted in the kernel, and it's actually in the kernel now. And the maintainer who accepted that patch didn't know that it was AI generated. So that raises some interesting questions. Also, it was a really good talk, and I recommend that you go back. The video is online. You can find it as part of the Linux Foundation playlists. But Sasha talked in general about the use of AI for a lot of different things. So using AI for maintainer tasks. So the workload for him and Greg and others who are maintaining stable kernels is just incredible. The number of patches that they receive and have to go back and look at and review. And so Sasha talked about using AI for maintainer tasks. So independent of just generating code, which is kind of what people think of for AI, there's these other activities that AI can help with. And I think we're going to see this a lot more in the future. We're going to see how to use AI as an effective tool while still navigating some of the issues that AI may bring in terms of code quality or in terms of legal issues already. It's already showing signs of being helpful. Sasha gave a pretty good testimonial about how much has helped out his work. And there, when you use AI in tools, in things like tool development, testing and code review, it's a little bit less controversial than when you decide you're going to actually ship AI-generated code. I can attest to that. Sony has a no AI generated code policy for products that go out the door. I think a lot of companies are in that position. And we'll have to see how it evolves in the next little bit. We'll talk a lot about AI. So, okay, which one is the...
This one.
That's one. Okay, so that raised some discussions on the mailing list. So another thing Sasha did, he's kind of the main AI proponent upstream these days. He also sent some patches to the kernel mailing list, which provide context for AI agents. And it's pretty amazing. If you have not played with AI, you can give it a set of instructions. You can tell it to read the coding style guide and abide by the coding style rules upstream. And so it's pretty interesting what AI can accomplish for you. And it sure looks on the surface like it's abiding by all the rules. One of the interesting things was that there was not a bug, but there was an optimization that was missed in the AI code that Sasha submitted. But he ran the tool a second time, and it found that optimization and added it and suggested a patch and formatted the patch and everything. So I was like, it's pretty amazing. But the discussions have raised the question, what is the kernel's official policy? Is AI-generated code acceptable? One of the things we really want to be careful of is we don't want an avalanche of what we refer to as AI slop, right? It's really easy for a junior engineer, it's easy for an engineer at any level to generate a patch using AI that you don't fully understand, right? And that is a maintainer's nightmare. And so we expect that there might be an avalanche of low-quality patches with subtle bugs, right? It may look good on the surface, but that's going to increase maintainer burden, and that's something we're really, really worried about. And there are still unsettled legal questions about the copyrights and the licensing. So those are important issues. The Linux Foundation actually does have a guide document, but it basically says it leaves the policy to individual projects. So Linux kernel has not adopted any official policy, and I think that's going to be a big discussion at the Kernel Summit coming up this year, is what our AI policy is going to be. So stay tuned for information on that. And then So these discussions are ongoing on both the kernel summit list and on the mailing list. Some of the things, some concrete proposals that have been suggested are proposals for commit annotations to say that you actually put a tag that a particular AI assistant is used. People want to include like the name of the AI assistant so they can tell over time if certain AI agents are kind of better at doing code than others. Or if they find out that like one has problematic licensing issues, they can go back and they have flags that they can go find code if it needs to get ripped out in the future. We'll have more to say on our AI views after more material. But anyway, there'll likely be discussions in December. So now is my turn to go through and kind of do a blast through technology areas. How are we doing on time?
15.
Oh, okay. We're already running over. So when I refer to a talk, if I don't otherwise say where to find it, I'll either say it's from ELC or from Embedded Recipes. Those are kind of the two of the main places that I'm referencing things from. And you can use the name of the talk or the person to speaker to find the talk. Let me talk about bootloader. There was an excellent talk by Simon Glass about the status of U-boot. So U-boot has a new way to organize the information about the boot sequence called boot flows. The legacy, if you've ever tried to set up kind of a system of managing your boot using the U-boot environment variables, it's really messy and kind of complicated, and you have to do a lot of kind of custom commands. It doesn't scale real well. Anyway, so he's come up with a new system called bootflow that allows distributions and machine vendors to put these bootflow files that are kind of config files that describe like where are the partitions or what is the nature of the partitions you might boot, what kinds of things they have on them. You can find, and these are discoverable by U-boot, and the intent is to simplify management of all this material. It's really good stuff. Some of the new features that are coming up are the ability to actually build without support for the command line. The U-boot command line has historically required a lot of scripting and stuff. And when you have these boot flows that are providing a lot of the information already on a machine, you don't need that necessarily. And if you configure out the command line, it turns out the command line support and all that scripting support was a pretty big chunk of the U-boot image size itself. You can actually get to the Linux kernel in about 100 milliseconds. So that's really good if you're working on boot up time. They're also, on the opposite end of the spectrum, they're also working on a GUI menu and a text editor. So they're bloating it in one direction and they're making it possible to go smaller in the other direction at the same time. But anyway, so check out that talk if you're interested. There is a boot up time special interest group. This one is near and dear to my heart. I've been working on boot up time for 20 years. You'd think we'd be done now. But we're planning on, you can find information about it here. We have monthly conference calls. Our next monthly call is coming up on September 23rd, and you're free to join. Our next kind of big project is we're working on a boot up time tools and tricks guide. There's a lot of them already out there. Some of them need to be updated. And we want to include, in this one, we want to include like kind of real data. So data from, we've written some test code and some new instrumentation code. And so that's some of the works. This is a list of some of the work that's going on in the area of boot up time. And so there's a lot actually kind of exciting. Well, if you're me, you find it exciting. I don't know how many other people find, like, oh, I shaved 10 milliseconds off the boot time. So Rust is coming in the Linux kernel, and John Corbett gave a great talk at Open Source Summit Japan, talking about some of the issues and some of the things that might be merged. I think he was prescient on the binder one there. But I heard this quote direct out of the mouth of Greg Crow-Hartman at the Linux Member Summit in November. And he said, quoting Linus, so this is hearsay, but Linus says the future of Linux is Rust. So if you if all you have on your shelf is the Kerningham and Ritchie C book, you might want to get a new book. And then file systems and I/O. So there are big performance games in the ext file system over both the 6.16 release and the 6.17 release. So that's really interesting to me. They're still finding lots of optimizations. Bcachefs might be on its way out of mainline. If you have questions about that, I had more bullet points here, but I will answer questions on the reasons why that might be happening. We can talk about it. Anyway, I'm going to leave it at that. Okay, so real-time preemption. Real-time preemption got into the kernel in, I can't remember the release, but 6.12 or 11, something like that. But it was it was actually in Vienna at Open Source Summit Europe, or associated with that when the pull request was made, so a year ago. So what do we need to do? Well, nothing's ever done in the kernel, right? So there's additional optimizations that are going on in the kernel to handle specific use cases. One of the things is we're going to see a lot more focus on, now that the infrastructure is in place in kernel, we're going to see how do you actually make your application real time? How do you guarantee, because just because the real-time support is there, the scheduling hooks and the priority inversion support and the mutexes and all that stuff, just because that's present doesn't mean your app is going to perform correctly. You have to use it correctly. You have to avoid certain things, and you have to do certain things like locking memory, pre-allocating memory. So increasingly what we're going to see is a shift in focus to tools that allow you to instrument code. One of the first ones here is this RTAP monitor. That detects, like for instance, page faults during a real-time process. Okay, if you've done your real-time right, you shouldn't be getting a page fault. A page fault is like bad news, right? You don't know the latency of that, and you should have pre-faulted your pages in and stuff like that. So this can detect all kinds of things. There's going to be more work on priority inversion handling. A couple of new features that are coming up are what's called lazy preemption. So they're kind of reworking. There were a couple of different preemption configuration options for the kernel. Preempt none, preempt voluntary, preempt full, preempt RT. So they want to replace that with a simpler system that allows you to get some of the benefits of preemption and do kind of less of this. Well, they want to restructure the code so that it's more automatic. One of the issues is that to achieve real time, they've sprinkled throughout the kernel source code these calls to conditional reschedule, and those are kind of like a voluntary release point, a yield point. But they're inaccurate. There's thousands of them, and they're hard to maintain. And so they've kind of come up with a new system to do this called lazy preemption. And this will actually replace the two other modes that we've done. And Thomas Gleixner has estimated that about 95% of the conditional reschedule calls could be eliminated, significantly reducing the burden to maintain real time over time. That was always one of my concerns, is that once we got it in the kernel, it would be difficult to maintain. We can't. It's not going to scale if we have to have a superhuman maintaining it on an ongoing basis. So the other thing that's coming out having to do with real time is proxy execution. So the way that we've handled priority inversion in the kernel so far has been with priority mutexes, I think, priority inheritance locks. And so that works when you're dealing with processes that are both in the real-time scheduling class. But it turns out that you also want to cover processes that are maybe not in that scheduling class. And so this is a different way to do that, where you can actually hand over the process or the flow of execution to another process that's maybe holding a lock or some resource that you need. The accounting is very tricky on this. It's not upstream, but some of the current work is to put some infrastructure in place to support that in the future. And there's some things that are remaining on that. And then in terms of testing, we got the Linux test project is kind of chugging along. There was a revival this year of the Automated Testing Summit. This is a testing summit that we'd had a couple years ago. It kind of died when COVID hit. That was not the only reason it died, but that was one of the reasons. But I think this is a good development. This is just a smattering of the talks that were at that. I think it's never been a better time to get involved with testing on the Linux kernel. You've got the kernel CI project, you've got K-self-test and K-unit that are both upstream places to submit tests for the kernel. A lot of really interesting talks and work in this area. Let's see. And then tracing. This is the weakest bullet point ever. ftrace, perf, and eBPF continue adding features. So go check them out. But I did see something at Embedded Recipes that I thought was really interesting. And actually, there was a talk also last year in Vienna. There was a talk on Perfetto. And that is a new tracing tool that Google has developed. It's the interesting thing about it, well, one of the interesting things, it's very mature. It's used internally by Google for Android work, but it supports SQL queries. So once you've collected a bunch of data, you can run SQL queries on it. And that allows you to kind of inspect the data. You know, most of the time with tracing, you're either looking through it by hand or you're visualizing it, which are both good techniques, but the ability to actually do kind of structured analysis using, you know, the metadata about the pieces, the trace points that you've caught is pretty interesting. Okay, and then this is a security topic, so I'm going to turn the time back over to Marta. Or there you go.
Yeah, this one I definitely need. So, if you haven't heard, the Cyber Resilience Act has been published in the official journal of the European Union many months ago. And it's going to apply as scheduled. Same for standards. And if you haven't taken time to understand how it works, what it means to you, and all of that, some resources, there is a training from the Linux Foundation, Understanding the EU Cyber Resilience Act. So it's a beginner level introduction. I did it in 15 minutes. It may take you a little bit more time. And there are resources for open source projects and users of two initiatives that are working on open source world response to the CRA. So there are resources from OpenSSF on the GitHub and for the ORC also on the GitHub. Links are here, all those resources that you can review on your own. Now on build tools and distros, we have news on Yocto project, Buildroot, and Debian 13 has been released as its own bullet point. On the Yocto project side, the latest version 5.2 has been released in May. It's not an LTS. It has some internal changes. The migration guide is there. And the Yocto project news for the recent months is that RISC-V has become a first-class citizen, and the next LTS will have an official support for RISC-V. Then there are also ongoing discussions on setting up your multi-layer configuration setups in the Yocto project. Currently, there are multiple out of 3 tools for that, with the notable mention for CAS. It allows you to configure your system when you have multiple different layers that you use to build a product. And there's a new initiative called BitBake Setup, which is similar to CAS, and the hope is to merge it to the mainstream of the Yocto project, but it requires way more review and testing from users. So if you're building a system with more than 3 layers, please have a look and review the tool.
Yeah, Alexander's got a talk on this.
And
today.
yeah, that's the main. And yeah, Alexander, if you have any questions, you grab Alexander and ask him for a demo.
He said he's going to do a demo first, which is very brave.
Then all Bidrot 8's getting strong. There is 2025-08 that's on the RC stage. There's long-term support 2025-02. Latest stable 2025-05. Yeah. And there's a link to the news. Now on the industry news. That's
Okay, so this we cut out a lot of information here that we normally have, but we'll just go through a couple of things. So Linux Foundation has a ton of projects that are in some way related to embedded. AGL obviously is, we consider automotive embedded. But we got the civil infrastructure platform, core embedded Linux project, unfortunately is shutting down. But we've got drone code, ELIZA, space grade Linux, kernel CI for testing, open chain for supply chain stuff, OpenSSF on security. Just some of this material is a little bit old. I think, Walt, is your talk, did you already give your talk or is it coming up? Tomorrow. So Walt's got a talk tomorrow. Give us an update on kind of what's going on with AGL. I want to talk about SGL because this one is near and dear to my heart. I found out a couple of years ago that Sony had a space division. So I started working on space stuff. So space grade Linux, how it started. We got together at NASA in December and we had a special interest group put together here. I just want to talk about Linux in space. Okay, so this is me and my grandkids on a hike in Utah. Behind us is actually Utah. And I know it's hard to see. In fact, it's impossible to see. But I knew when this picture was going to get taken, and I went outside my house and I waved at the camera. So I'm in this picture twice. But this is the reason I brought this up is this is a satellite called SelfieSat or SatGus. It's running Linux, and it's actually running 5 instances of Linux, and it's using an ARM flight computer from Tyvek International that's running Linux. It's running. They have because they were paranoid about fault tolerance, they actually have 2 complete stacks. So they have Raspberry Pi Compute Module 4 that's actually kind of driving the payload. And the payload in this case is their Pixel smartphone. And they have duplicated. They actually have 2 Pixel smartphones and 2 Raspberry Pis. So that's a total of 5 computers running Linux. And they're just using ADB, right, to communicate between the Raspberry Pi and the Pixel smartphone with ruggedized USB. So this is the type of way that Linux is being used currently. We'd like to kind of make things a little bit more formal in the Space Grade Linux project with things that are known to be tested well and architected for radiation tolerance in outer space and that type of thing. So, but I think in terms of like a use case, I think embedded stuff in space is probably the most embedded you can get. It's really an extreme environment, a lot of requirements. And now let's get back to AI.
So that has been like 10 minutes that we haven't talked about AI, right? So there are AI systems, especially the learning system, that are scrapping open source projects and their public sites for data for training. And they are not frequently they are not behaving really well. And there were many projects that had an important cloud bill because of that. So they started implementing gateways, firewalls, and other things, and even blocking entire countries in some cases. So it's a serious problem. LWN is also affected, and other sites too. It's hard to deal with those things. And to add to that, there is fake content that is showing up, like bug reports and security vulnerability reports generated by AI that are hallucinating on things like function names and things like that. And the same thing on Stack Overflow that has issues with fake content, with incorrect data in it. So we are facing it. Then Ubuntu, we stopped the AI subject. The Ubuntu change in core utilities has brought coverage because of two things. First is that they allow testing a core utilities version written in Rust. And secondly, because the new tooling is licensed MIT, while the old tooling was licensed GPL. So there are two controversies in one. Then, on the community and conferences, what has happened in the recent months? We have the Open Source Summit Japan that was in December, FOSDEM in February, Linear Connect in May, Embedded Recipes also in May, and LC Americas in Denver. Presentations and slides for all of those events are available with interesting content. And what's coming soon, there's Open Source Summit Japan in Japan, and Plumbus this year is also in Japan. It's in Tokyo just after Open Source Summit. So that changes the typical schedule, but this year it is like that. And I know that calls for presentations for LPC are out.
So we're like basically out of time, but we're gonna plow through anyway, real quick. Some of the themes. I think over the last, not just AI tools, but we're seeing a lot of other tools. So one of the things you see is feedback-directed optimization. That was kind of a theme at last year's Plumbers. We're seeing AI. We're going to have to deal with that. One of the things I've noticed is that we're a mature ecosystem. Well, it shouldn't have taken me 20 years to notice that, but we have ways of dealing with problems that we didn't have 20 years ago. And I think John kind of commented on like one of the things that we need in the modern era is we need lawyers and we need an HR department. And one of the things that you realize is that the Linux Foundation is doing those types of things for us. So we have a code of conduct committee that is handling issues, and they're kind of unsung in the background working away. We have, and then we have a legal team. We have essentially an HR team. We have someone who's managing intellectual property for us. We actually have someone managing the payroll for us. Linux does actually have a payroll. We have people who are paid to be maintainers, and an accounting department and an IT department and that type of thing. AI was not on my bingo card for something that would crop up. It has, just in the last 2 years, I think, it's just really come on strong. We have to be careful. We do have to be careful. We don't want to get into a situation where we introduce a bunch of subtle bugs into the kernel because we're not mindful. We also need to be really careful of maintainer time. We've always needed to be careful of maintainer time. And there's some burden risk there. There's also legal risk. So my personal opinion is we need to be very conservative with accepting AI code into the kernel. And so that's it on my views.
On my views, I've seen LLMs causing real hallucination problems, especially security related, so like inventing API calls or inventing packages that do not exist and allow attacker to create a package with such a name, and well, bad things happen. And what I can say is that there is imbalance in the power between people who use AI and can with automation and can generate hundreds of thousands or either commits or reports or analyze hundreds of packages, and maintainers who do not have time to configure those tools, and they are left into handling them manually. And that's a real problem that we'll need to have solved, because people doing analysis of automated things manually, they are not going to win. That's very clear.
Okay, so now my retrospective. I'm going to try and do in like 1 minute what John took 30 minutes to do. When I got involved with Linux, in 1993, 32 years ago. And I was involved, okay, I apologize. I was involved with the creation of Caldera. So, but then I went on to, I was at Lineo when the whole SCO thing happened, so don't, anyway. But I was at the Embedded Linux Consortium that worked to promote embedded Linux because no one believed in it back then. The Consumer Electronics Linux Forum when it was just starting to take off in the in consumer electronics. And the Core Embedded Linux project that later merged under the Linux Foundation. And so each of those kind of organizations had different roles in the maturity of. In the 90s, it was a different era. No one believed in Linux. They didn't believe in it in embedded, for sure. They didn't believe in it on the desktop or in servers. There was no Git. There was no Bitkeeper. Linus was using patches and tarballs and emails. There was no lore. I think we take for granted lkml.org was just getting started. There was no Google when we started. There was no methodical release product. There was no code of conduct. But there were some communication norms. No trademark, no legal protection, only one tool chain. So it was a different world back then.
And when I started around 2000, that doesn't seem to be at all an important point on my timeline because I do not remember how I started. I was testing too many things. That was the time when I was using CVS in my first job, and I already knew that there are better things because I was using Subversion in KDE. If you do not know, in CVEs doing branches, that's quasi impossible. So one of my first projects was creating an IP tables module to normalize networking packets because at the time network stacks were still crashing when they received funny packets. Yeah, and to start summing up, so what do we worry about? About the AI? As you can imagine, it's already putting stress, but it's also a powerful tool. So what's going to happen in the future? That's an open question. And what worries me personally is that many companies are replacing junior developers by AI those days. So then the question is, who is going to become seniors at the end? On the maintainer side, we have maintainers that are reaching the retirement age. So what's going to happen? Who is going to replace them? Fortunately, we have some young people that are taking over. But on the other side, I noticed that the universities do not teach low-level hardware stuff to other courses than electrical engineering. And then you get someone who knows Python and Java, and you want to teach them about interrupts, memory structure, and such things. That takes a little bit of time. And then we have tools that could break network effects or improve test coverage depending on how you look at that, because the kernel could now be quite different depending on where you compile it on. But to sum up, we have a full room on these talks, and we are going very well. We have a lot of interesting content all the time. The embedded Linux is running on billions of devices. I do not know if we haven't, in fact, moved on the other unit already. And the core kernel has subsystems that support embedded. And of course, there's still new hardware coming in, while some areas still, like the favorite space of Tim, still have some barriers for adoption. And it's still not done.
So join us in continuing the evolution of Linux. There's some of the resources that we use. You probably noticed a shameless amount of references to LWN.net. But we also get stuff from Phoronix, kernel newbies, Linux Foundation newsletters, and of course the kernel mailing lists and Google. While we're on the subject of LWN.net, I'll put out a little bit of a plug here. I have been a professional subscriber for at least 10 years. I don't know when I started. But this is an absolutely invaluable resource for looking up information. And it's surprising how relevant the information is, even when it's old. Some things in the kernel don't change very fast. But if there's a subsystem in the kernel, you can almost always find discussions about that subsystem when it was introduced and when it was modified. And so I highly recommend the LWN.net kernel index. And so also, you could go out and get your own subscription and have your company subscribe and stuff. I think they're a valuable resource. And that's it. And I don't know if we have time for questions.
We do not. We are already during the lunchtime.
We're already during your lunch, so I apologize.